Okay, Assalamualaikum and very good evening to all of you. Welcome back to our class, the BAA2213, the Reinforced Concrete Design 1. So in this video, I will discuss about the design of steel reinforcement for beam, which considering the flange. Okay, this example is based on the example 1.6 from the module. Okay, sorry, let me have my. Okay, this is the answer sheet exercise number 7. Okay, let us do this as exercise number 7. Okay. Sorry, I have to skip exercise number 6 and we will do it by next class. Okay, exercise number 7. So, okay, let me check whether I'm recording or not. Yes, I'm still recording. Okay, exercise number 7. This is the data. Okay, the T-beam. We have the T-beam, where the value of B is equal to, here is equal to 400 mm. The HF, I want it to be 135 mm. Okay, the D is still 400 mm and the BW is also 200 mm as the example. Okay, so this is the, and the applied moment is 250 mm. Okay, applied moment is 250 mm. This one, applied moment is 250 mm. Okay. So as this one, you can refer to your module later, okay, with some adjustment. And so what we are going to do is we must refer back to this, okay, to these notes. I believe you have these notes, okay. Design procedure for flange sections is divide. Okay, first of all, if you are given the bending moment and you want to design the flexural reinforcement for flange sections, so you must check the, first of all, you must check the value of MF. If the value, okay, by using this equation, you don't have to worry. I believe this equation will be given during the final exam. Okay, and then if the MF is greater than or equal to the MED, this, which is the design moment, so the neutral axis is in flange. If the neutral axis is in flange, so you can proceed the design with as rectangular section, as we did for exercise 1, okay, for rectangular sections. Okay, and then if the value of design moment is greater than the MF, okay, MF we check from these equations, means that the neutral axis lies below the flange, and then we can proceed with the calculate the M balance by using this equation, okay, beta F times FCK B times D square. The beta F can be calculated by these equations, and then if the design moment is lesser or equal to M balance, we design as singly reinforced, where the AS can be determined by using this equation. And if the design moment, okay, in our case, the design moment is this one, okay, the bending moment. This is MED. Okay, MED is equal to 250 kilonewton meter. So, if the design moment is greater than M balance, means uh, the the compression reinforcement is required, so it can be calculated, okay, by using this equation before the area of steel for tension can be calculated based on these equations. Then you can check the AS minimum and AS maximum as exercise 1. Okay, so let's do this example first. So the first of all, as here we check the MF. Okay, the solution is, okay, I don't have to write down. Okay, okay, B is equal to 400 mm. Okay, HF is equal to 125 mm. D is equal to also 500 mm. B is equal to BW. BW is equal to 200 mm. Okay, before we have FCK is equal to 25 Newton per millimeter square, and FYK is equal to 500 Newton per millimeter square. And then given MED is equal to 250 kilonewton meter. So the solution is, first we check the MF. Okay, by using these equations, okay, MF is equal to 0. Okay, MF is equal to 0.567 times FCK times BHF, okay, times D minus 0.5 HF. Okay, so just insert the value. 0.567 FCK is equal to 25. B is equal to BW, which is the B is the longest one, the effective. Okay, HF is equal to 125, and then D is equal to 400 minus 0.5 times 125. Okay, may I have the answer?
239.
Okay, good. 239 kilonewton meter. So which is, this one is lesser or greater than MED?
Lesser.
Lesser than MED. So where is the neutral axis? Below or within the flange?
Within the flange.
Inside the flange. Lies below the flange. Okay, this one MED. Oh yes, because MED is greater, right? MED is greater. Okay, so MED is greater. So neutral axis below flange. Okay, so we have to check, and then second one, we proceed to second step, which is to check, calculate the beta f, which is equal to beta f directly from these equations. Okay, we can use these equations, the beta f. It's okay, just write down these equations. Beta f is equal to 0.167 BW over B plus 0.567 HF over D. Okay, 1 minus BW over B and multiply by 1 minus HF over 2D. Then equal to 0.167 BW is equal to 200 B over 400 plus 0.567 HF is equal to 125, D is equal to 400. Okay, multiply by 1 minus 200 by 400, multiply by 1 minus 125 over 2 times 400. Okay, can I get the answer? What is the value of beta F? 'Anybody have the answer?
.158.
Okay, good. 0.158. Thank you. And then once you have the BF, so you can calculate. Okay, according to this step, once you have the BF, you can calculate the M balance by using these equations. So step number 3 is calculate M balance is equal to beta F times FCK times B times D square, which is equal to beta F is equal to 0.158 times what? FCK is 25 times B 400 times 400 square. So what is the value now? M balance.
Sir.
Okay, 252. Okay, 252 kilonewton meter. Okay, is it greater than or equal to MED? Compared to MED, M balance is 252. This is greater than MED. Okay, so we treat is singly reinforced, this one. Okay, so greater than MED, therefore we can conclude that it is singly reinforced. Okay, so and then the next step is singly reinforced. You can calculate the AS by using these equations. Okay, let's finish what we had started. Okay, step number what? Step number 4. Okay, very simple. Step number 4, calculate the AS. So AS is equal to, be careful lah, be careful. M, okay, you must multiply by 10 to the power of 6. Okay, this is the equations. M plus 0.1 F CK times BW times D multiplied by 0.36 D minus HF divide by 0.87 FYK multiplied by D minus HF over 2. So just insert the value carefully, be careful. 250 times 10 to the power of 6. So plus 0.1, FCK is 25, BW is 200, D is 400. Okay, multiplied by 0.36 times this one. Be careful lah, be careful. 0.36 times 400 minus this one. Okay. Okay, this one first. Minus 125. Okay. And then divide by 0.87. FIK is 500. And then 400 minus 125 over 2. And then what is the S prime? S required? Okay. Anybody can have the answer?
1728.
Okay, good. 1728 mm square. So what can you propose? Provide. What can we provide? Okay, you can refer this table. Okay, this table.
CH20.
Okay, 6H20, good. 6H20, 1885. Okay. 6H20 where AS provided is equal to 1885 mm square, or any other answer?
For H25.
Okay, here. Okay, good. Or 4H25, the AS provided is equal to 1963 mm square. Okay, so this is our example exercise number 7, but this one is for singly reinforced because the MED is greater than MED, okay, which is 250. Okay, this one 250, lesser than M balance. Okay, what if, okay, we still have class up to 5:50, so you can use these 20 minutes, repeat this exercise 7. Okay, let's say this is exercise 7A, and do exercise 7B. Okay, 7B. Exercise 7B is still similar value, but for exercise 7B, you change the, okay, exercise 7B. Okay, the MED is equal to, okay, 275 kilonewton meter. Okay, procedure is still similar, but you just increase the value of MED, so it will be doubly reinforced. Okay, it will be doubly reinforced, so you can check the AS prime and AS by using this equation. So, do you have these notes, or you want to print screen? Okay, I believe you better screenshot these notes. Okay, to calculate the AS prime and AS, and then I will provide you with the Google form, and then you have to submit the Google form, which contain the exercise 5, exercise 7A, and exercise 7B. Exercise 7E we did just now, which is the singly reinforced, and exercise 7B is doubly reinforced. Okay, have you screenshot this one?
Yes, Doctor.
Okay, thank you. Thank you very much for your answer. Okay, I can stop sharing now. And thank you very much for your answer. I will continue with example. Exercise 6 is very simple, so I don't think I have to do it, because it is strongly related to exercise 1. Okay, we just, because the exercise 6, okay, if you check your module, which is module 1 from example 1.5, the natural axis lies in the flange. So that's why I show you exercise 7, which is below the flange. Okay, so thank you very much for your attention. Have a nice day. Please submit later your exercise 5, exercise 7A, and exercise 7B as a proof of participation. Thank you.